What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
We don't often publish articles on some self-designs, still there are more specialized editions for them. But sometimes it happens in particularly interesting cases. The very design of gasoline diesel stove indirect heating, where the fuel burns inside the boiler heat exchanger, which is blown from the outside by a fan to get a stream of hot air, not an invention of the leading companies in this area such as Webasto or USSR. It existed long before their appearance. The Germans simply perfected the well-known scheme and details and equipped it with various service electronics. For many years, the USSR had its own Überspecher in the form of the heating system of our most famous air-cooled car, the Zaporosts. Both humpback ZAZ 965 and eared ZAZ 968. There was no hot antifreeze jacket around the Zappa engine, and there was no place to take the heat. Therefore, the factory workers had to design the heater as a completely independent device, independent of the engine. The decision is quite typical for its years. The same autonomous gasoline stoves were in other cars with air engine in bourgeois Porsche and in socialist Camp Tatras. What is interesting, in the eared ZAZ 968 this stove stood in front, that is, in the front trunk, and heated only the interior. But in the older ZAZ 965 it was located behind, in the engine compartment next to the engine, and had a separate pipe, from which the hot air was directed to the upper casing of the engine. In thrust the heater acted as a preheater. The same heater produced by Shadrinsk Auto Aggregate Plant SHAZ was used on much less widespread LUAZs, as well as on various construction and specialized equipment, often not having gasoline engines in principle, for example, on tower cranes or in various control cabs. And, as it often happens, there was a mass curiosity. In its native place, the stove SHAZ caused streams of hatred from Zaporovoditely, but being taken out of the ears, had popularity and demand, not decreasing to this day, even in the XXI century. Why it happened so? The ZAZ Pachika had a number of unpleasant features. Firstly, it consumed a lot of fuel, almost like the main engine of the car. Secondly, ignition of gasoline was carried out in it by glow plug, which consumed more than 1.5 tens of amperes of current. And during short trips quickly discharged the battery even with quite serviceable generator. Thirdly, the heater was very noisy. The roar of air and the whistle of motor bearings could drown out even the main engine. And, finally, the peculiarity of popular thinking for some reason excluded the heater from the number of units requiring maintenance. As a result of which many people had it permanently clogged with soot, poorly heating, unstable starting and stinking gasoline in the cabin. That did not contribute to love neither to the stove in particular, nor to Zappa in general. By the way, it is worth to clarify for the generation of TikTok, this iconic car from Jerks was always called Zappa, with emphasis on A. Not Zappa, as for some reason many people think. As a result, it became popular among handy car owners to convert the Zaporov heater to gas power and spark ignition. This allowed it to start almost instantly, to work economically, not to emit unpleasant odor, and to consume 1 ampere of current for ignition instead of 16. After such renovation, the SHAZ stove worked successfully in Zaporozhye, where a 5-liter cylinder with liquid propane was enough almost for the whole winter, and for heating garages and in various other equipment. Connoisseurs of Russian Webasto heated vans, trucks, motorhomes and similar vehicles and trailers. Of course, this option is suitable only for those who are ready for some locksmith and electrical work. However, for remodeling Zaporov stoves are now actively taken even by amateurs. Instructions on the internet a lot, and the cost of the stove from 500 to 1500 rubles pays for the effort, because even nameless Chinese clones of the German car requires 10 to 12,000 rubles. In its standard form, the heater includes a boiler, a carburetor, a blower turbine, covers for connection to the air duct system of the car. Actually, many people start the modification and overhaul of the heater with covers. They are often just thrown out completely, because in their original form they are optimized for Zaporosts and are practically meaningless when using the heater outside it. The basis of the whole heater is a boiler heat exchanger made of stainless steel. Gasoline is injected inside it, air is blown in for combustion, and the exhaust is discharged outside through a large pipe with a massive flange for bolts. On the photo it is on top. The boiler is shoved into a flimsy casing, a tin pipe painted with heat-resistant silver paint, like a roofing pipe. A carburetor, very similar to a real carburetor, with a float chamber, needle, jets and even a built-in solenoid valve that cuts off the gasoline supply when the heater was turned off, is responsible for powering the heater. Why the quotation marks? Because, in fact, the carburetor is primarily engaged in the preparation of fuel-air mixture, and carburetor stove ZAZ fed only. Fuel and mix it with air was not engaged. Therefore, it is more correct to call it a gasoline dispenser, not a carburetor. Strictly speaking, when converting the heater to gas, this carburetor is absolutely unnecessary. It can be unscrewed and scrapped. And the power doser for the heater in the converted to gas version is a joker, any kind of bushing, with an opening of 0.8-1, 0 mm. Not a standard joker of the carburetor, but a homemade, made from scratch, suitable or drilled, taken from some carburetor from the engine. In what place of the supply path will stand this joker, it is not important. At least directly in the connector coming out of the heater, at least in any point of the rubber gas hose. You can even solder the supply tube with a 100-watt soldering iron, and then drill a hole in the solder plug with a thin drill bit 0.8-1, 0 mm. The blower turbine in the ZAZ is a coupled one, two different impellers are mounted on the motor axis. The first one, metal, left, works in the hot zone. It is inserted when assembling the heater into the cavity of the combustion chamber and blows into it the air for fuel combustion, which is sucked in through the side pipe on the photo above. This air is then exhausted to the outside in the form of exhaust gases. The second impeller, right, is plastic, larger, and it is engaged in blowing air over the outer surface of the heated boiler and removing heat. This air just goes into the car interior. The flows from the two impellers are separated and do not mix. The peculiarity of the heater motor ZAZ in its low efficiency due to the small impeller of coaxial design, as in its timber. Coaxial heater fan VAZ 2101-2007 was inferior to the centrifugal fan VAZ 2108-99, noise and tendency to die due to the souring of bronze graphite bushings in which the rotor rotated. And, despite the low efficiency of blowing, it roared and howled, even fresh and serviceable, quite mature. A curious element of the heater was a thermal switch, a powerful micro-switch button with a contact triple. The button was fixed in a bracket with a long metal tube sticking out of it. When the thermal switch is mounted with a cap nut in its place of operation, this tube is in the combustion chamber, in the flame itself. Inside the tube is a thin quartz rod, which moved a couple of millimeters when the tube was extended from heating, switching the button. The glow plug and the blower motor are normally connected via this thermal switch in the ZAZ. After the stable combustion was established inside the boiler, the thermal switch automatically de-energized the glow plug, and further. The combustion was self-sustaining. And after turning off the stove, the thermal switch for some time before it cooled down supplied power to the blower for afterburning of fuel residues, blowing and cooling of the boiler. When converting the heater to gas and spark ignition, the thermal switch is sometimes kept, sometimes not used. It is not necessary to disconnect the spark plug, unlike the glow plug, with it, although the gas can also burn perfectly well by itself. It is more reliable when the spark will be on the electrodes of the plug permanently. If for some reason the torch goes out, it will instantly flare up again. And the current consumption of spark ignition is negligible. If the standard thermal switch is left, then as a timer to ensure blowing the boiler after shutdown and to control the gas electro valve about it will be below. In any case, if the standard thermal switch is not used, it must either stand in its rightful place unconnected, or instead of it, must pick up some kind of plug. For its absence creates a hole in the combustion chamber. The native glow plug for gasoline ignition is called ZAZ65A, and it is, strangely enough, still produced and can be purchased. Of course, you won't find it on every corner, but in large auto parts stores it can be found for 350 to 400 rubles. The plug is installed in the combustion chamber through a copper washer and pressed down with a cap nut. Propane it is not able to ignite, and when the heater is converted to gas supply, the standard spark plug is completely scrapped. Only the fixing cap nut and sometimes the removable glow plug cover with slots protecting the spiral need to be saved. Actually, you should not look for a ready-made spark plug for spark ignition, which could be simply screwed in bolt-on instead of a glow plug. There are no candles with such threads in nature. They are made artisanally from ordinary car plugs without any problems will fit and already working, unworn. If you use a modern compact and slim plug with a wrench for 16, its metal hexagonal part is slightly machined so that it passes into the hole of the seat, and the length of the threaded part of the standard cap nut would be enough to fix the plug. If you use a candle with the classic dimensions of a 21mm wrench, you may not be able to sharpen its metal part. The diameter and height are not yet close to the required diameter and height, but a cutter, file or bolt cutter will already reach the thick ceramic part. In this case, you can cut off the metal elements from the candle completely, shorten part of the ceramic insulator, shorten slightly the central electrode and its tip bent sideways. On such a candle, put on a removable casing from the native glow plug, serving as for centering and acting as a side electrode. And this Frankenstein is put in place through the same native copper gasket. It is quite a workable variant. As a source of high-voltage spark, homebuilders use different variants. The simplest one is easy to find in the mass of reports on redesign of ZAZ stove, a primitive generator of impulses from the usual 5-pin automobile relay which commutates the usual automobile ignition coil. The variant is quite workable, but unreliable and noisy. There are no questions about the coil reliability, but the relay in the continuous crackle mode does not work for too long. Also widespread is the variant of spark generator from an ordinary commutator from carbureted front-wheel drive ZAZ in tandem with the emergency ignition unit, AZ1. The variant is quite reliable, although bulky. And those who are friends with a soldering iron make the simplest homemade electronic generator, switching the coil. Actually, after making the spark ignition, it remains to connect gas to the stove from the usual refillable propane cylinder with a reducer of any capacity, suitable and mobile 5-liter, and stationary 50-liter. Some homemakers supply gas to the stove directly from the cylinder, unscrewing the valve on it, and others, through a normally closed electric valve from the car gas equipment included in the path after the valve on the cylinder. There is no difference in the end result, just an electric valve in series with the manual valve does not make using the heater a little safer if it is turned on through the above-mentioned thermal switch. In that case, the gas will be shut off when the thermal switch cools down, when suddenly the stove goes out for whatever reason. Nevertheless, the gas valve is not critically necessary. The main thing is to strictly observe the sequence of starting and turning off the heater. First turn on the blower motor and spark generator, one common button, and then the gas is supplied by turning the valve and opening the electric valve or just turning the valve if the valve is not used. The sequence is exactly the same, not vice versa, which is fraught with explosion of the boiler overfilled with gas with soot emission. In a light variant, or even with destruction of the boiler integrity, switching off takes place in the reverse order. First, the gas is shut off and then, after about 5 minutes, the blower fan is switched off. This delay is necessary to expel the residual unburned gas and to cool down the hot boiler. To eliminate the human factor in the algorithm for starting and shutting down the heater, often self-modelers make the simplest relay circuit that does not allow you to confuse the sequence of actions and provides an automatic delay on the blow, either with a standard thermal switch or on different Kopechi timers from AliExpress. Well, and to summarize, it is possible with traditional recommendations of accuracy and caution. Gas is not a scary thing, as many people mistakenly believe, but only if you are careful and attentive. In conclusion, the Webasto system from the USSR represents a fascinating blend of innovation and practicality, showcasing how a simple autonomous stove can enhance comfort in vehicles like the ZAZ. Its ability to provide reliable heating in various conditions makes it a valuable asset even today, especially for those who venture into colder climates or seek to optimize their vehicle's efficiency. By understanding its mechanics and applications, we can appreciate the ingenuity of past technologies and their relevance in our modern lives. Thank you for watching, and we hope you found this exploration of the Webasto system insightful.